Students, this is the last chapter in the practical applications of Bernoulli's theorem. So, what is this topic means? Force exerted by a flowing fluid on a pipe bend. So, you know that whenever the pipe was bent, that means we need to change the direction of the fluid flow. Okay. So, what we have to adopt? There will be a bend or elbow. Okay. So, during that passage of the fluid flow, it turns into some other directions. At that portion, that the corner portion, that curved portion, exerted some force. Okay, due to the flow of fluid in that pipe. Okay, exerted some force. So, how to calculate that force? So, that is the major thing in this chapter. So, this topic will highly helpful for design of the bend and elbows. Okay, so that bend and elbows must withstand that high load, high force. Okay, impact on that bend and elbow. Okay, so if the fluid is flowing in a horizontal pipe or vertical pipe, means nothing happen, no problem. If if we want to change the direction of the pipe, we have to provide one elbow or bend. Okay, so for design for that thickness of the bend or elbow, so we need to calculate the force acting on that bend and elbow. Based on that, we have to design that bend and elbow. So let us see how to calculate. Okay, so you can see here there is a first initially a straight pipe is there. Okay, a straight pipe is there. So after that, the pipe is turned to some angle. That angle is theta. That angle is theta. Okay, so due to this changing direction, okay, the sum of the force, that means Fx force acting in the horizontal direction parallel to this pipe. Okay, parallel to this pipe, and there will be Fy force. Fy force is acting perpendicular to this pipe. Okay, there are these two important forces are acting on the pipe. Okay, so we need to calculate the forces in that pipe. So here you can see here B1, consider two section 1 and 2. So this is section 1, this is section 1 and this is section 2. That means before bender and after bender. Okay, consider two sections. V1 is the velocity of flow at section 1. So here velocity V1 and P1 is the pressure intensity at section 1 and A1 is the area of cross section at the section 1. So same way at section 2. Okay, so at section 2 you can observe that during that pipe bend, okay, there will be a vertical as well as horizontal vertical velocity and horizontal velocity is acting. Okay, see, actually this is the V2 is the velocity parallel to the bend. Okay, so since it is inclined manner, there will be horizontal component as well as vertical component also occurs. Okay, so let Fx and Fy be the components of the forces exerted by the flowing fluid on the bend in x and y directions respectively. So this is Fx, this is in horizontal, and Fy is the vertical. Then the forces exerted by the bend on the fluid in the directions of x and y will be equal to Fx and Fy, but in the opposite direction. Okay, so what is the meaning of this means? The force exerted by a bend, okay, on the fluid. Okay, so if the water is flowing in the, assume the water is flowing in the pipe, when it strike the bend means what happens? There will be opposite forces occurs. Okay, so there will be an opposite forces occurs. So that is this acting in the opposite direction. Hence, a component of the force exerted by the bend on the fluid in the x direction, which is equal to minus x. So there will be opposite force here, minus Fx, minus Fx. Okay, so again minus Fy, minus Fy is occurs. Okay, so the other external force acting on the fluids are P1, A1. So this is pressure, this is area. Pressure into area is nothing but that fluid force. So same way P2, A2 on the section 1, section 2 respectively. Then the momentum equation in x direction is given by, what is that momentum equation? So what is that momentum equation? Momentum means what? Mass into velocity. Okay, mass into velocity. Here you can see here, net force acting on the fluid in the direction of x. Okay, net force is acting on the fluid on the direction of x equal to rate of change of momentum in x direction. So both, this is the condition. Net force which is equal to rate of change of momentum. So force P1 A1 minus P2 A2 cos theta. Okay, so you can observe in this picture. So this is the P2 A2. Since the bend is an inclined, okay, it changes the direction. So this is P2 A2. The horizontal component of this is P2 A2 cos theta. So it is acting in the opposite direction. So put minus. So this P1 A1 and this P2 minus P2 A2 cos theta minus Fx. So this is the Fx acting on the opposite direction, minus Fx, which is equal to mass into velocity, momentum. So how to calculate mass? Mass is equal to density into discharge. Final velocity in the direction of x minus initial velocity in the direction of x. Discharge into velocity. Okay. Final velocity minus initial velocity. Okay. So rho into q into v2 cos theta. Okay. So here in this picture you can see this is v2 cos theta minus v1. So this is the final velocity and v1 is the initial velocity. Okay. So pq into final velocity minus initial velocity, v2 cos theta minus v1. So fx, okay, final fx is equal to, here minus fx is there. Okay, finally fx is equal to pq v2 cos theta minus v1. You can write this one, and this portion, okay, this portion coming to this side. Okay, so plus. So here minus is there, minus comes this side means plus. P1 A1 minus P2 A2 cos theta. This is equation number 6.18. Similarly, the momentum equation in y direction. So this is Fx. This is force acting in x direction. Come to y direction. So y direction, there is no vertical force is acting. Here only horizontal force. This is only horizontal force. There is no vertical force. So 0 minus P2A2 sin theta. You can see here P2A2 sin theta. This is vertically downward acting. So minus P2A2 sin theta minus Fy. So what is Fy? Fy is acting here, downward direction. This is Fy. Okay, which is equal to same formula, mass per second into change of velocity. So PQ into V2 sin theta minus 0. Okay, so V2 sin theta minus 0. So there is no initial velocity in the y direction. So Fi is equal to rho q minus V2 sin theta minus, so this portion is coming to this side, means minus P2A2 sin theta. Okay, so this is the formula. Okay, so now the resultant force Fr. Okay, so here we calculated two forces, that is x direction as well as y direction. Now resultant force acting on the bend is root of Fx square plus Fy square, Fx square plus root of Fx square plus Fy square. Okay, this is the resultant force acting on that bend. Next, under the angle made by the resultant force. So under what angle this result force acting? So which is equal to tan theta is equal to Fy divided by Fx. So tan theta is equal to Fy divided by Fx. So from this we can easily calculate the how much force resultant force is acting and in direction of the force, magnitude and direction. Okay, so let us see one problem for better understanding. I read the question. So a 45-degree reducing bend. Okay, a 45-degree reducing bend. Reducing bend means the diameter, this is the original pipe diameter, and this reducing bend diameter is different. Okay, is connected in a pipeline. The diameter at the inlet and outlet of the bend is 600 mm and 300 mm. Okay, find the force exerted by the water on the bend. If the intensity of pressure at the inlet to bend is 8.829 Newton per centimeter square, and the rate of flow of water is 600 liters per second. 600 liters per second. Okay, so angle of bend. So here angle of bend is given 45 degree. Next D1 600 mm. You convert it into meter, 0.6 meter. Next corresponding area of the pipe. A1 is equal to pi by 4 into D1 square. So pi by 4 into 0.6 square. This is 0.6 square. We get an answer 0.2827. Okay. Next come to diameter of outlet. So diameter outlet how much? 300 mm. So 300 mm you convert it into meter, and the corresponding A2 pi by 4 into 0.3 square. So we get one answer. So next, pressure at inlet. What is the pressure at inlet? 8.829 Newton per centimeter square. You convert it into meter square. So into 10 power 4. 8.829 into 10 power 4 Newton per meter square. Next, discharge. So here, please note down, discharge is given in terms of liter per second, not meter cube per second. So we must convert into meter cube per second. Okay, so 1 meter cube is equal to how much liters? 1000 liters. So 600 divided by 1000 is 600 divided by 1000. So which gives the 0.6 meter cube per second. Okay. So next V1. V1 is equal to Q divided by A1. So Q is 0.6 and area is 0.2827, which is equal to 2.122 meter per second. Next V2 Q divided by A2 0.6 divided by 0.07068, 8.488 meter per second. So now applying Bernoulli's equation. So the first step is calculation of area and calculation of velocity. Once discharge is given based on the area, we can easily calculate the velocity. So now I am applying the Bernoulli's equation on both section 1 and section 2. So P1 by rho g plus V1 square by 2g plus Z1, which is equal to P2 by rho g plus V2 square by 2g plus Z2. So this is the Bernoulli's equation. Okay. So now so Z1 and Z2 both are in same datum line. Okay. So because pipes turn in horizontal direction only, not in vertical direction. So pipes is turned like this. So it goes straight and it will turn like this. Okay. Not in vertical direction. Vertical direction means definitely Z1 and Z2 will come. Okay. So now Z1 equal to Z2, so both get cancelled. So P1 final equation, P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g. So why we need to apply this equation? Mean to calculate the pressure head at section 2, because pressure is at section 1 only pressure is given. For section 2 there is not pressure not given. Okay, so initially we have to find the pressure head for the section 2. So substitute all the values. That means P1 by rho g, P1 by rho g, V1 square by 2g. This is P1 by rho g, this is V1 square by 2g, and this is V2 square by 2g. So the only unknown is P2 by rho g. So calculate P2 by rho g from this equation, simplify, we get 5.5575 meter of water. Okay, so from this rho we know, g we know, from this we can easily calculate the P2. So 5.5575 into 1000 into 9.81 Newton per meter square. So the pressure on the section 2 is 5.45 into 10 power 4 Newton per meter square. So keep it in remember, if pressure pressure is not given, means you have to calculate using the Bernoulli's equation. In some cases, they definitely give pressures at two sections. Okay, in this question, at section 1 only pressure is given. Section 2 pressure is not given. Okay, so we have to form. That is the second step. So now applying the equations, we already found in the derivation. So first apply the equations. So this is the fourth step. Forces on the bend in x and y direction are given by equation number 6.18 and 6.2. We already know. So fx. So previously we calculate this equation. Okay. So fx is equal to rho q v1 minus v2 cos theta plus rho p1 a1 minus p2 a2 cos theta. So from this we can calculate the fx value in terms of Newton. Next, Fi value PQ into minus V2 sin theta minus P2 A2 sin theta. So Fi is equal to minus. Okay. So you can observe Fx is plus, Fi is minus. Okay. Minus 6322.2 Newton. So minus indicates negative force. We don't bother about answer is came minus. So how to do? So no problem. Definitely, it is charges is available. Okay. So here you can mention like this. So minus value sign indicates Fi is acting in the downward direction. Okay. So it may be acting positive or negative, whatever may be. So no problem. So find the resultant force. So resultant force Fr is equal to root of Fx square plus Fy square. Okay. So finally, so we got the equation. So root of this is plus value. We seen Fx value is plus and Fy value minus. If you minus square means that also plus. It can automatically changes. So finally 20890.9 Newton. So this is the this much of resultant force is acting on that bend. So you can see in this picture. So this is Fx in horizontal direction, positive direction, and Fy we got minus direction. That means downward direction. And this is the Fr. Fr is the resultant direction, resultant force. Now we have to calculate the theta value from the horizontal. How much angle of direction? Okay. So the resultant force is acting. So we know that the angle made by the resultant force with the x-axis. So please note that it is not from y-axis, it is from x-axis. Is given by equation 6.22. So tan theta is equal to Fy divided by Fx is equal to 6322.2. This is Fy value. And so here don't put minus. So minus sign indicates only direction. Okay. So here don't put minus. If you put minus means answer will not come. Correct answer. Okay. So not required. Minus value not required. Only value you can write. So Fx value 19911.4. So finally we got tan theta is equal to 0.3175. So always this answer will come less than 1 only. Okay. So from this theta, so how to calculate theta? So tan theta is equal to this value. Okay, theta is equal to tan inverse of 0.3175. It is 70 degree 36 minutes. Okay, so this is the simple problem. Only you have to memory this Fx formula. That means this Fx formula, Fy formula, and Fr formula. Fr formula is root of Fs square plus Fy square, and tan theta is equal to Fx divided by tan theta is equal to Fy divided by Fx. That's all. So once you understand this, the equation, three equation means this type of problem is easy. See, actually this problem is asked in last semester, October 2020, last month they conducted that supply exam. In that supply exam, the same question was asked. Okay, so this also important question in Bernoulli's equation. So I hope all of you understand this problem. So up to this three in third unit, first chapter is over. Okay, half of the portion is over. So next class we will see the notches and VS. We will start notches and VS. That is the second part of the third unit. Okay. Okay. Thank you, students. Thank you very much for your understanding. Okay.